Hi guys, my name is Choke Emmanuel. Welcome back to the fourth part of my series whereby I'm still working largely on analytical geometry problem. Please have a pen, have a calculator, have a notebook so that you get notes. And then one more other thing is that please don't forget to subscribe the channel so that you get more videos as I upload. So I want us to read what we are given so that we see how we're going to solve some of the question. I think about 7 questions that I want us to work. But before I work them, I want us to understand what's going on in the circle itself. Let us read. In the diagram below, M is the center of the circle having the equation. So now what they are giving us is the equation of the circle. So I'm going to highlight that equation of the circle. It is given as such. Now there are 2 points to really pay attention to as well, and that is the circle passes through R and N. The circle passes through R and N, where R is 0 and -4 and N is P and Q. One more other thing is that RM, I'm gonna highlight that RM, that angle is equal to 90 degrees, meaning that it is perpendicular RM is perpendicular to RN right there. It is given as well by that angle of 90 degrees. The tangents are drawn to the circle at R and N meet at P. So you have 2 tangents that meet at P, and those tangents are stationed at R and N, like that. So I want us to identify a few things before we continue. We have got the equation of the circle. Just gonna highlight that carefully so that we all see what's happening in there. I'm just gonna highlight that carefully. So this is what we have as the equation of the circle. If you look at that equation, it is not written in a form whereby you can see the radius and the coordinate of the center as well. So what I will then do is I'll try and write that into that format whereby I have to get the coordinates of the circle center. Of course, it must be in standard form, but otherwise, let us read what we have. We are saying that determine the coordinates of the center M. You need to find the coordinates of the center M. So how do you find that? You are given the equation itself. I'm just gonna do it like this for you guys. You are given the equation. So the equation is x squared plus y squared minus 6x plus 2y minus 8 equals to 0. So I have to write this equation in standard form in order for me to get the center and also to get the radius. But how do I do that? I hope you guys know the basic of this chapter is to complete the square of this equation. But before I complete that, allow me to write this equation in a proper way, whereby I'm going to say, well, this is going to be x squared minus 6x plus y squared plus 2y. I'm going to transpose the constant that side, so it's going to be positive 8. So now I want to complete the square. I'm going to look largely at the coefficients of x and y, which are these coefficients. I'm going to complete the square along those coefficients. So what I will then do is I'm going to take the half of -6, and I have to square that. So half of -6 is going to be -3, and then I have to square that -3. It's going to be +9. So when I square when I square it, it's going to give me 9, and then I have to add both sides of the equation. So I'm going to do that quickly. So now I'm going to have a x squared minus 6x. I have to add the half of the square of that coefficient of x, which is going to be a 9, plus, and I have y squared plus 2y. Now I have to take a half of that coefficient of y, which is 2. So if you take a half of 2, you're going to get 1, and you have to square that 1. Remember grade 11 stuff, and then you're going to get a +1. And then these numbers right here, I'm just going to highlight them. These numbers 9 and 1, they have to be added both sides of the equation. So but now you have positive 8, you must add positive 9 and positive 1. These numbers which I was telling you about, that you must add them both sides of the equation. No, thank you very much for that. So now what I will then do is I'm going to make this first expression here the perfect square, even this one to be a perfect square, so that I can get my center there. So how do I do that? I'm gonna say to myself, well, this is going to be x minus 3, and then I have to square that. If I expand that, it's going to give me back x squared minus 6x plus 9. I hope you know how to do this one. And then the plus, if I make this one a perfect square, it's very much easy as well. It's just going to be y plus 1, and then I have to square that. That equals to 8 plus 9, which is basically 17 plus 1, so it's going to give me 18. So this is the equation of the circle where you've got the center. By the way, they are still looking for the center here, and you have answered that question part. So now I'm going to say, therefore, the coordinates of the center, these are the values there. So it's going to be positive 3 and negative 1. That is the coordinate of the circle center right there. So I'm gonna highlight that point. So this is the point M. I might need that. Normally, if the first question is done wrong, you struggle for the preceding. So this is the coordinates of the circle center. You can see that x is positive at that point, and then y is negative. It's negative 1, and then x is what? Is positive 3. Now I'm gonna go to the second question of the series. They are saying that determine the equation of MR in the form of y equals to mx plus c. The equation of MR, let us write the point m. The point m now, it's what? It's 3 and negative 1. I want us to find the equation of MR where I've got everything now. So what I need to do is to get the gradient of MR. So this is going to be y at r minus y at m divided by x at r minus x at m. So what is x at r? I'm just going to do it like that. What is x at r? X at r is 0 minus what is x, sorry about that. I'm talking about the y value now. Y at r is minus 4 and minus y at m, which is minus 1. So it's going to be negative 1, and I have to divide that. X at r, which is 0 minus x at m, that is going to be positive 3 in that case. So now if I work that out, it's going to give me the value in the numerator. It's going to be negative 3 over negative 3, which then gives me the value of what? Of positive 1. So this is the gradient of MR. It's the gradient of MR. So I need to get the equation of that line MR. I can choose any point between M and R. You know, grade 11 work. This one you can take any point, either M or R. So I'm gonna take R because at R I see there's a y cut there. This line is gonna pass, it's gonna cut at negative 4. So I'm just gonna say my C is negative 4, but if you want to solve it, you say to yourself, you've got the equation y equals to mx, where m is the gradient and is 1 times x. It's gonna be x plus c. So I'm going to say at the point r, I'm taking the point r now, which is 0 and negative 4. So this will then mean that y is negative 4, x is 0, plus c, like I said, so your c is going to be negative 4 on the basis of the evidence that you have the point r where you have got the negative 4 as the y cut of that line. That is why you have c as negative 4. Then you will then say to yourself, therefore the equation of the line MR is going to be given by x minus 4. for the value of c there. It is important to highlight what we found, because it might be needed down there or in some other question, we don't know. So this is what we have so far. The third part, they are saying that we have to prove that q is equals to 2 minus p. We want to show that q equals to 2 minus p. So to do that is very much simple, beautiful people. Okay, I was saying then, well, let us look at what we have. We have got the gradient of mr, which is 1, and mr is perpendicular to what? To mn. So I'm gonna write that for me, so that it helps me. So I'm gonna say, well, mr is perpendicular to mn. The reason this one was given to us, so we write given in that case. So we know the gradient of mr is the one which we found. So this means that the gradient of what? Of mn is going to give us -1 if the gradient of mr is 1. This implies that the gradient of mr is what? Is -1. But now I can find the gradient of mr. How do I find that? I have the points m, I have the point n. So I'm going to say to myself, therefore, the gradient of n is going to be y at n minus a y at m divided by x at what? X at n minus a x at m. This will be, what is y at n? That is, let's check that. Y at n is q. So this is going to be q minus y at m. Y at m is that one of -1, so it's going to be -1 divided by x at n, which is p, minus x at m, which is +3. So I'm going to say to myself now, we know that this gradient of mn, it is equals to -1. So I'm going to say this is -1 equals to, you have q minus -1 is +1 divided by p minus 3. Remember here it's over 1, so you can cross multiply, which will then be q plus 1 equals to -1. I'm just going to do like this, -1 -1 into p minus 3. So let's see that. We're going to have q plus 1 equals to -p plus +3. I'm going to transpose a 1 that side. So this is going to be q equals to -1. I have +3, and then I have a -p there, which will then mean that the value of q is going to be given by what is -1 plus 3. This gives us 2, and then we have minus p. This is how we prove that the value of q is going to be given by 2 minus p right there. So I'm going to highlight that as well. So we have the value of q, which was proven to us that it's going to be given by 2 minus p in that case. So now let's check the next question. If you have any question on how I'm doing it, please let me see that in the comments, so that I can explain to you guys. Now we are saying that hence or otherwise determine the values or value of p and q. We have to solve the values of p and q. I'm going to look at where p and q are. The value of p and q belongs to the point n. So in that n, it passes through the circle. What I will then do is I'm going to take that point and substitute it into the circle and see what do I get. Now to do that, I have the equation of the circle, which was given by x minus 3. X minus 3 squared plus y plus 1 all squared is equal to 18. So the point and x at n is p, y at n is q. I'm going to substitute the point n into that equation and see what I get. Let us do that together now. So I'm going to say, well, substitute the point n, which is p and q, into the equation of the circle. How do I do that? What is x at n? It's p minus 3. I have to square that, plus what is y? It's y, it's q. So I'm going to write q, just plus 1 there, and then I have to square that, and then this equals to 18. Now we know what is the value of q. You can do it vice versa. You can substitute a q was 2 minus 1, or you can substitute p. In that case, in you solve vice versa. It's not really a crisis. So what I will then do is very simple. I will say to myself, since I know the value of q, let me do it in this way. I'm gonna say, well, I'm gonna substitute the value of q. So this is going to be p minus 3 all squared plus q. I see q. What is q? Q, I know it's 2 minus p plus 1. In that case, let me just do like that and bring back my color. So it's plus 1, and then I have to square that, equals to 18. And then now we're going to have I'm just gonna remove the brackets carefully. So this is going to be, let me just first simplify that out. So this is going to be p minus 3 all squared plus, you're going to have 3 minus p all squared equals to 18. I don't have to really stress out. I can do it like this. This is going to be p minus 3 all squared, because this one looks like it's the same as that one but opposite sign. So you can say to yourself that is basically the same as what as p minus 3, and then just bring back my color there, and then I have to square that equals to 18. Some might ask me, how do I get that? What you do is you say to yourself, it's 3 minus p all squared, which can be written as you take the negative and then you write a p minus 3, and then you have to square that. So if you remove the brackets here, you're going to get back that stuff. So it's basically the same thing, but I want to play some algebra right there. So this is going to be negative 1 all squared into p minus 3 all squared. This is basically the same thing as that one right there. And then now I'm going to get a positive 1 and then into p minus 3 all squared. That is why I just moved the inverse of that. So it's not really an issue there. Just the basic algebra, which I advise you guys to really be careful of that. And then now I'm going to say to myself now, so this is twice of the same stuff. So it's going to be 2 into p minus 3 all squared equals to 18. Then now I can divide everything by 2. I'm going to get p minus 3 all squared. This equals to 9 if I divide everything by 2. So I'm going to get p minus 3 equals to plus or minus 3. I'm squaring both sides now, so this will imply that this will be 3 equals to positive 3 plus 3. Then it's gonna give me positive 6, or p equals to 3 minus 3, which is 0. So I'm gonna check at that point. at the point which one can best represent P. So P is a positive 6. It can't be 0 at that point. So therefore, I'm going to say that P at that point, P cannot be equals to 0, but P is what? It's 6. So I'm going to say to myself, therefore, P is going to be a positive 6. So I want to get the value of Q. Now, from number 3, I have Q is equals to 2 minus P. So I'm going to use that equation. I will then say, therefore, you have Q equals to 2 minus P, where P now you have a P. So P it's 6. So I'm going to say this is 2 minus the value of P, which is 6. Then let's see what do we get now. We get the value of Q. The value of Q is going to be -4. So I'm just going to highlight that for you guys. I'm just going to highlight that for you. So this is the value of P. We have solved that, and then this is the value of Q, which is -4 in that case. So now I will say to myself, what it means is, it means the coordinate of N is what? It's P, which is 6, and -4. These are the coordinates of N that I have solved. This is how I'll go about that. You could have substituted P in terms of Q. It will still be fine. There's no issue about that. And then now I'm gonna go to the fifth equation. They are saying to us, determine the equation of the circle having a center O passing through N. So this O, let us check this O. O was the origin. If you guys check that, O is the origin. So I'm gonna write the equation of the circle when it passes through the origin. So we're going to have this equation, the circle, when it is in the origin, x plus y squared is equals to r squared. This is when the circle is in the origin. So you need to get the value of r squared. So we are saying that this circle passes through what? Through N. So I'm gonna say at N, which is that one there, which I'm told that the circle passes through. So I just need the 0.6 and -4 to substitute back into this one, and then I'm gonna get the value of r squared. Let us do that. So you're going to have 6 all squared for x, and then plus y. What is y? Y is -4. I have to square that, and that gives me r squared. So this implies that the value of r squared is what? Is 36 plus 16, which is 52. Which is 52. You can try and work it out, and you guys will tell me what you get there. So here we were looking for the equation of the circle passing through N. So it's the circle in the origin. So I'm just going to write the same thing. So it's going to be x squared plus y squared is equals to r squared, where r squared is equals to 52. So this is how you get that equation right. It's very easy. It passes through N. And then now we're saying to you guys, calculate the area of the circle centered at M. Centered at M. We want to get the area of the whole circle centered at M. So I'm gonna ask you now, how do you find the area of the circle? You are going to write the formula for the area of the circle. You're going to say to yourself, the area is going to be found by pi r squared, where r is the radius. So now I'm gonna say where r is the square root of what? Of 18. Remember, you had the circle here, which was x minus 3 all squared plus y plus y plus 1 all squared is equals to 18. So this is r squared, it's not the r. So if you want to get the r, you have to square that 18, which in this case gives us the square root of 18. So then now the area will be pi, the square root of, the square of r, which is the square root of 18 all squared, which then gives us what, 18 pi. But because we're dealing with the area, we must write square units. We must write square units. If you want to round it off into two decimal places, you're going to get 5 6 comma it's 5 6 comma 5 5, but you must still write a square units that you must write.